Architect Divya Chakravarti. She completed her undergraduate studies from SRM University and she went on to pursue her master's in historic preservation and urbanism and study of the built environment from the University of California, Los Angeles. She went on to work for the Department of Planning and Preservation for the city of Pasadena, California. She also did a brief stint of work for Historic Scotland, Edinburgh, UK. She also worked on conservation projects like Kalsa Mahal, Gokhale Hall in Chennai, and Marimalappa Educational Trust in Mysore. She is currently working as a director of Samrakshan Heritage Consultancy. She is also a co-founder of the Artisan Reprisal of Traditional Materials, Method and Technology. She goes on to conduct workshops to revive traditional and lost methods of construction.
Welcome to the UGC lecture series for Bachelors of Architecture. The subject we are discussing is environmental science, and the topic we will be delving into is environmental pollution. In this lecture, we will be looking into soil pollution, marine pollution, and noise pollution. Soil pollution and its remedies. What is soil? Soil is the thin layer of organic and inorganic materials that covers the Earth's rocky surface. It is composed of particles of broken rock that have been altered by chemical as well as mechanical processes that include weathering and erosion. Pollution of soil is basically defined as anything of buildup in soils of persistent toxic compounds, chemicals, salts, radioactive materials, or disease causing agents which have adverse effects on either plant growth or animal health. Soil pollution is also caused by means other than the direct addition of xenobiotic, that is man-made chemicals such as agricultural runoff waters, industrial waste materials, acidic precipitates and radioactive fallout. Causes of soil pollution: seepage from a landfill, discharge of industrial waste into the soil, percolation of contaminated water into the soil, rupture of underground storage tanks, excess application of pesticides, herbicides or fertilizer, solid waste seepage, deforestation and soil erosion. Now, when you have excess application of pesticides, it is thought by many farmers and people all over that a sturdier crop is a healthier crop, which is actually not necessarily true. Sometimes excessive pesticides could lead to further harm than it would do any good. Excessive use and disposal of plastics and polythene waste. So, because of this, again the topsoil sometimes gets clogged, or it sometimes clogs certain water canals and the movement of water and other irrigation facilities. Industrial seepage, solid waste seepage, especially from landfills, and every city ends up having 3 to 4 huge landfills covering acres and acres of land, making it pretty much infertile for any future use, because especially in developing countries like ours, garbage is never segregated as hazardous and non-hazardous. It's all dumped in one place. So, heavy metals, batteries, computer parts, domestic garbage, vegetable waste, everything gets dumped in the same place. The most common chemicals involved in causing soil pollution are petroleum hydrocarbons, heavy metals, pesticides, solvents. Types of soil pollution: agricultural soil pollution, which is basically pollution of surface soil, pollution of underground soil, soil pollution by industrial effluents and solid waste. This is again pollution of surface soil and disturbances in soil profile, which can be seen not only immediately but over a period of time as well. Pollution due to urban activities. This is again pollution of surface soil as well as pollution of underground soil. Agricultural soil pollution. Plants on which we depend for food are under attack from insects, fungi, bacteria, viruses, rodents and other such animals and must compete with these weeds for nutrients. To kill unwanted populations living in or on their crops, farmers use pesticides. The remnants of any such pesticides used on pests get absorbed by the soil particles and contaminate root crops grown in that soil, especially if crops like potato, root crops like groundnuts, all of that means it's even entering the food chain because the crop itself gets contaminated. The consumption of such crops causes the pesticides remnants to enter human biological systems, affecting them adversely. Agricultural effects: reduced soil fertility, reduced nitrogen fixation, which again becomes a part of a vicious circle, because when you have reduced nitrogen fixation, farmers are dependent on external fertilizers or nutrient specific fertilizers to add on for that nitrogen in the soil. Again, because of excessive nitrogen, there will be other repercussions that they have to face. Increased erodibility, larger loss of soil and nutrients, deposition of silt in tanks and reservoirs, reduced crop yield, imbalance in soil fauna and flora. Agricultural effects: industrial soil pollution, large quantities of solid waste like unused and rejected chemicals like sludge, press mud, sawdust, bottles, plastic materials, etc., or any unwanted industrial waste generated during different manufacturing processes are basically dumped on the surface of soil by almost all industries with difference in the degree. Larger the production base, larger is the generation of waste. Traditionally, these materials have been dumped around the factory site or entire city. Rarely are they put in anything like incinerators, and even incinerators cause air pollution. So, it could either be water pollution where it enters different water bodies, or it would be soil pollution where the basic components of the soil get altered. Industrial effects: dangerous chemicals entering underground water, ecological imbalance, release of pollutant gases, increased salinity or percentage of salt, reduced vegetation. Industrial effects over here, you can see polluted land with dangerous chemicals, and they don't realize that herbivores like deers or goats, cows don't realize that it's being poisonous. They eat it, and then sometimes even human beings as secondary carnivores consume these animals, and it enters the human ecological system. This is soil pollution due to industrial waste. You can see a particular soil sludge, oil sludge that is being created over here, which is slowly irradiating and reducing the quality of greenery, reducing the quality of grass as well as plant life, which is then going to adversely affect other animal life and human life eventually. Soil pollution due to urbanization. Urban activities generate large quantities of city waste, including several biodegradable materials like vegetables, animal waste, paper, wooden pieces, carcasses, plant twigs, leaves, cloth waste, as well as sweepings, and many non-biodegradable materials such as plastic bags, plastic bottles, other plastic waste, glass bottles, glass pieces, stone or cement pieces. On a rough estimate, Indian cities are producing solid city waste to the tune of 50,000 to 80,000 metric tons every day. If left uncollected and undecomposed, they do lead to a series of several problems. Urbanization effects: clogging of drains, inundation of areas, public health problems, pollution of drinking water sources, foul smell and release of gases, waste management problems. Soil: you have soil pollution by heavy metals, soil pollution by pesticides and organic contaminants, soil pollution by nitrates and phosphorus, soil pollution by artificial radionuclides. Heavy metals: even sometimes factories, because they do not want to be caught, what they end up doing is burning their waste in incinerators, and that again causes huge problems with air pollution, and like we discussed, it later leads to formation of acid rain or acid precipitation. Heavy metals. Soil contamination by heavy metals such as cadmium, lead, chromium, copper, zinc, mercury and arsenic is a matter of very great concern. These are basically naturally present in the soil, but their levels are constantly increased by industries, non-ferrous industries, power plants, iron, steel and chemical industries, agriculture, that is irrigation with polluted water or use of mineral fertilizers, waste incineration or burning of waste, combustion of fossil fuels and road traffic, that is basically exhaust from automobiles. Pollution of agricultural soils by heavy metals may lead to reduced yields and elevated levels of these elements in agricultural products and thus to their introduction into the food chain. Heavy metal deposits on grassland soils remain predominantly in the top few centimeters and are directly ingested with the soil by grazing animals. Heavy metals are toxic and inhibit the soil's microorganic activity. Their concentration in the soil can remain for decades or even centuries. Reduction of heavy metal emissions is the most direct way to decrease the atmospheric deposition of these elements and their build up in the soil. Despite a great increase in traffic, for example, a reduction in lead emissions has been achieved through incentives to use unleaded petrol. Implementing complex measures that reduce soil acidification could more efficiently reduce heavy metals. On agricultural land, heavy metal quantities can be decreased by using low metal content resources, especially for fertilizers, replacing inorganic pesticides with organic products and other similar methods. Nitrates and phosphorus. Nitrogen and phosphorus are elements essential to all forms of life and are therefore relevant to soil systems as well as food crops. Although they are very important plant nutrients, excessive application may lead to nitrogen or phosphate saturation in the soil and eventual contamination of the groundwater as well. The amount of leaching depends on the soil, the local climate and the style of crop management. If you look at phosphorus, phosphorus basically accumulates in the upper layers of the soil in regions with high livestock densities. That is where you have more cows, goats, etc. In soil saturated with phosphorus, especially those with shallow groundwater, high phosphorus concentration occurs in the upper groundwater layer and in the surface water, resulting in eutrophication. Moving on to nitrogen. The problem of nitrate pollution is recognized internationally and is usually associated with intensive agricultural practices. Good agricultural practices that alleviate the problem are the selection of crops that require fewer nutrients, a timely application of fertilizer that is only during the growing season, improved methods of manure application, shortening the length of the grazing season, reducing the intensity of grassland use, that is by lowering the density of cattle, because when the pesticides or any such fertilizer is going to be used in the maximum growing season, if you let grazing animals at that point of time, the chances of the elements entering the food chain and the food system is much higher. So, it's important that we regulate the grazing season as well as the application season of these materials. Pesticides and organic contaminants. Pesticides pollute the soil directly by affecting the organisms that basically reside in it. Soil, however, can act as a vector for the pollution of surface water and groundwater. Organic pollutants enter the soil via atmospheric deposition, direct spreading onto land, contamination by wastewater as well as waste disposal. In addition to pesticides, organic contaminants include many other components such as oils, tars, chlorinated hydrocarbons, PCBs and dioxins. There is such a wide variety of organic substances that their detection and monitoring in the soil is practically impossible. And another main issue with any of these things is it cannot be constantly monitored every cycle of crops. It can only be done when, say, land is going to be bought or sold, or if there is a water body which is noticing certain changes in eutrophication or changes in plant or animal life. But to ensure that there is a regulatory mechanism, it's important that farmers keep their eyes open, and as well as knowledge is dispersed amongst farmers that what kind of crops, what kind of fertilizers and pesticides can be used to enable a healthy agricultural life as well as crops as well as ecological cycles. The use of pesticides can lead to destruction of the soil's microflora and fauna, which leads to both physical as well as chemical deterioration, severe yield reduction in crops gradually, leaching of toxic chemicals into groundwater, and potentially threatening drinking water resources. Primordial radionuclides. Primordial radionuclides are left over from creation of the earth. They typically have lives of hundreds of millions of years. Examples include uranium-235, uranium-238, thorium-232, potassium-40. These radionuclides end up in soil as a part of the rock cycle, which includes weathering. Tree or plant roots dig deep down into the cracks of earth, prying these rocks apart, turning it into the soil. Natural radioactivity in soil varies on soil type, mineral makeup as well as density. Man-made activities such as mining may accelerate the movement of these radionuclides into the soil. These are effects of urbanization, landfills, contaminated of water and soil waste. You can see the landfills and collection of plastic bags right by water bodies, and this could be a water body that's now basically become a huge puddle. Some more effects of soil pollution. Pollution runs off into rivers and kills the fish, plants and other aquatic life. Crops and fodder grown on polluted soil may pass the pollutants on to the consumers. Polluted soil may no longer grow crops and fodder. Soil structure is damaged, that is, clay ionic structure gets impaired permanently sometimes. Corrosion of foundations and pipelines, which will again lead to other problems eventually, may release vapors and hydrocarbons into buildings and cellars, may create toxic dust, may poison children while playing in the area. Impact of soil pollution. People living near polluted land have higher incidences of migraine, nausea, fatigue, miscarriage, skin disorders. Long-term effects of pollution include cancer, leukemia, reproductive disorders, kidney and liver damage, as well as failure of the central nervous system. Children often suffer from developmental problems and weakened immune systems, especially near radioactive zones where they don't even realize that the soil is quite naturally radioactive. If nothing is done to clean up soil pollution, water supplies could also become contaminated, either again because of groundwater or soil water runoff, threatening human species. Sudden fires or explosions will occur from underground landfill gases. Pipelines and building structures may corrode, and once beautiful regions will turn into cesspools. A lot of these experts are constantly sending out warnings. Some more effects of soil pollution: dead aquatic life and clogged up soils and water bodies. And another view of soil contamination. Excavation showing soil contamination at a disused gas works. So, even though this particular gas works site has been closed for a number of years, when a part of the soil was excavated, you can see the level of pollution it has undergone. A couple of feet under, nearly 5 to 6 feet under the surface of the soil, which means the groundwater is getting polluted as well as the basic fertility of the soil is lost. Soil contamination or soil pollution as a part of land degradation is caused by the presence of xenobiotic or human-made chemicals or other alteration in natural soil environment. It is typically caused by industrial activity, agricultural chemicals, or improper disposal of waste. So, this type of contamination typically arises from failure caused by corrosion of underground storage tanks, that is piping used to transmit contents. It could be pipelines taking natural gas, it could be pipelines taking fuel, petrol, anything. Application of pesticides, percolation of contaminated surface water to subsurface strata, oil and fuel dumping, disposal of coal ash, leaching of waste from landfills, or direct discharge of industrial waste to the soil. The most common chemicals involved are petroleum hydrocarbons, lead polynuclear aromatic hydrocarbons such as naphthalene and benzopyrene, solvents, pesticides, and other such heavy metals. This occurrence of this phenomena is correlated with the degree of industrialization as well as the intensities at which different chemicals are particularly used in those industries. The concern over soil contamination basically stems primarily from health risks, from direct contact with contaminated soil, vapors from contaminants, and from secondary contamination of water supplies within underlying reach of these soils. Mapping of contaminated soil sites and resulting cleanups are time consuming and very expensive tasks requiring extensive amounts of geology, hydrology, chemistry, computer modeling skills, GIS and environmental contamination, as well as a basic appreciation of history of industrial chemistry. In North America and Western Europe, the extent of contaminated land is best known, with many of the countries in these areas having a particular legal framework to identify and deal with such environmental problems. Usually, huge industrial conglomerates have an insurance policy just to avoid such suits of environmental degradation and health hazards resulting from this. Developing countries tend to be less tightly regulated despite some of them having undergone significant industrialization. So, this is like we are aware of the dangers because other parts of the world have already undergone it, but we are not willing to put our foot down and say this is not going to be allowed here, because as developing countries we cannot lose out on any chance of industrialization, any chance of foreign investments, and this is our basic attraction over here, because we do not have stringent laws protecting the environment and different levels of pollution. Most people are starting to outsource their production and manufacturing jobs over here. So, this type of contamination or pollution is typically from corrosion of pesticides, corrosion of underground storage tanks. So, industrial waste get discharged into either the groundwater or the surface of different kinds of ground fillings come into being, and heavy metals are sometimes there permanently settled into the soil, and this affects not only the growth of plants but also enters the food chain and then eventually the human part of the ecological system. So, we need to be aware of landfills, hydrocarbons from petroleum products, solvents, and especially heavy metals that are naturally occurring, as well as from the occurrence of effluents from industrial plants as well as power plants. Treated sewage sludge, known in the industries as biosolids, has become controversial as a fertilizer to the land. As it is a byproduct of sewage treatment, it generally contains contaminants such as organisms, pesticides, and heavy metals other than soil. Contaminated or polluted soil directly affects not only human health but also indirectly, because it is in direct contact with soil or via inhalation of soil contaminants which have been vaporized. This poses a greater threat because infiltration of soil contamination leads to groundwater, then aquifers, which is used for human consumption, not just for immediate human consumption but many decades or centuries down the road. And sometimes you will not then realize what is it that has caused this contamination. So, these areas are far removed from any apparent source of above ground contamination, because water, as you know, travels along with the force of gravity and other powers of current. So, when above the ground, when you are noticing certain factories and power plants, it is not necessary that only the soil below those plants or immediately around those plants are going to be contaminated. You don't know which area is going to get contaminated and how far this contamination is going to reach. Chronic exposure to benzene at sufficient concentrations is known to be associated with higher incidences of leukemia or cancer of the blood. Mercury and cyclodians are known to induce higher incidences of kidney damage, and some of these cases are irreversible damage. PCBs and cyclodians are linked to liver toxicity as well. Organophosphates and carbamates can induce a chain of responses leading to neuromuscular blockage. Looking at cleanup options, cleanup or environmental remediation is analyzed by environmental scientists who utilize field measurement of soil chemicals, but also apply computer models, especially GIS in environmental contamination, for analyzing transport and fate of such soil chemicals. So, various technologies have been developed for remediation of oil contaminated soil or sediments. There are several principal strategies for remediation. Excavate soil and take it to a disposal site away from ready pathways for either human or sensitive ecosystem contact. This technique also applies to dredging of bay muds which contain high levels of toxins. Aeration of soil at contaminated site with attendant risk of creating air pollution. Of course, we have to be aware of which is a worst known devil. Air pollution, once it goes to a state of water vapor or air vapor, it becomes difficult to control as it dissipates over a larger pace of area. But what happens when it's in the soil? It goes through it has the same effect but with groundwater as well as aquifers, which lead to contamination not only for immediate purpose but also for centuries down the road. Thermal remediation by introduction of heat to raise subsurface temperatures sufficiently high to volatilize chemical contaminants out of the soil for vapor extraction. Technologies include ISTD, electrical resistance heating (ERH), bioremediation involving microbial digestion of certain organic chemicals. Techniques used in bioremediation include land farming, biostimulation and bio-augmenting soil biota with commercial available microflora. Extraction of groundwater or soil vapor with an active electromechanical system with subsequent stripping of contaminants from the extract. Containment of soil contaminants, that is by capping or paving over in a particular place. Phytoremediation or using plants such as willow to extract heavy metals. Microremediation or using fungus to metabolize contaminants and accumulate heavy metals. So, when you end up using different kinds of plants as well as parts of the soil structure itself to reduce the contamination level in the soil, there is nothing better than that as a great option, because we can identify certain plant species that absorb certain extra heavy metals, and those can be planted in areas where heavy metal poisoning is noticed. So, this needs a lot of study with respect to plant life, geology, soil, everything needs to be studied, and it is an interrelationship of all these types of study. At the end of this lecture, we have seen soil pollution. We have looked into the effects and impacts of soil contamination. We should be able to answer the following questions. What is soil? What is soil pollution? Discuss the primary sources of soil pollution. What are the impacts of soil contamination? That brings us to the end of this lecture. Thank you.